This lecture we are going to learn about Fermi energy level. And Fermi Dirac distribution. Okay, first we will see what is Fermi energy level. As per the quantum theory, the electrons are staying in the discrete energy levels. Okay, so let us assume that in each and every level 2 electrons will be there. For example, you can take sodium 1s2, 2s2, 2p6 and 3s1. So like this, energy levels are there, several energy levels are there, and in the outermost level one electron is there. Now what is Fermi energy level means? The topmost filled energy level. The topmost filled energy level at 0 kelvins is known as Fermi energy levels. That means if you can see this one, so this level, the topmost filled energy level is known as a Fermi energy level. Now what is Fermi Dirac distribution? This Fermi Dirac distribution is nothing but a concept. Okay, so this Fermi Dirac distribution is nothing but probability of finding the electron above the Fermi level, below the Fermi level and in the Fermi level. That means how the conduction process takes place as per the quantum concept. So if you can give a little bit of energy, okay, so if the energy electron absorbs and it jumps into the empty levels, then those electrons participate in the conduction process, and there will be no excitation takes place in between the filled energy levels. As per the quantum concept, they have explained like this. Now Fermi Dirac distribution explains how the occupation of electrons will be above the Fermi level, below the Fermi level and in the Fermi level. So the Fermi and Dirac have given one equation is probability of finding the electron P of E is equal to 1 by e power E minus EF by kT plus 1. E is the energy of the electron in a particular energy level, EF is the energy of the Fermi level and K is the Boltzmann constant, T is the temperature. Okay, so according to the Fermi Dirac distribution, so they have considered the three cases. In the first case, they have taken the energy of the electron is less than energy of the Fermi level at T is equal to 0 Kelvin. Then what will be the probability of finding the electron? P of E is equal to 1 by 1 plus e power E minus, in this case E minus EF is E is less than EF and E minus EF becomes negative. So negative value by temperature is 0. So 1 by 1 plus e power minus infinity and 1 by 1 plus we can write e power infinity. So 1 by 1 plus 1 by e power infinity is nothing but 1 by infinity, that is nothing but 0, that is 1. So when energy is less than Fermi and energy of the electron is less than Fermi energy level, that means there is a probability of finding the electron is 1. That means the levels which are below the Fermi energy level, you can find the electrons. You can see the diagram. So the topmost filled energy level is nothing but the Fermi energy level, and below the Fermi energy level all the energy levels are filled states are available. Now in the second case, if you can see E is greater than EF and T is equal to 0 Kelvin, then the probability of finding the electron becomes 1 by 1 plus e power positive by 0. That means 1 by 1 plus e power infinity, the value becomes 1 by infinity, that is equal to 0. That means when the energy is greater than EF, that means the states which are having the energy value is greater than EF, the probability of finding the electron is 0. That means the energy levels which are above the Fermi level all are empty, and the energy levels which are below the Fermi level all are filled states. Now in the third case, they will see E is equal to EF, and here in this case T is not equal to 0 kelvins. It is greater than 0 Kelvin. The probability of finding the electron P of E is equal to 1 by 1 plus e power 0 by kT, because it is not 0 temperature. 1 plus e power 0, 1 by 1 plus 1, you will get 1 by 2. That means 50% of electrons are available in the Fermi energy level. So there is a 50% of chance of finding the electrons. So what are the final conclusions of the Fermi Dirac distribution? So they have explained simply in one graph. On x-axis they have taken the energy, and on y-axis they have taken the probability of finding the electron. So two cases, one they have taken the value 0.5 and 0. So okay, so below the Fermi, this is the at the Fermi energy level, what is the probability of finding the electron? 0.5. And when the energy value is less than EF, the probability of finding the electron is more. That means this graph tends towards 1. Okay, then if energy is greater than EF, this graph tends towards 0, because the probability of finding the electron is 0. That means this one simple graph explains all these three cases in a simple manner. That means at E is equal to EF, the probability of finding electron is 50%. When E is less than EF, all the below the Fermi energy levels, all the states are filled, and above the Fermi energy level, all the states are empty. So as per the Fermi Dirac distribution, the electrons which are below the Fermi energy level, they can take the energy, absorbs the energy. If you can supply the energy which is equal to kT, okay, they absorb that energy and they move to the empty levels, and those electrons can participate in the conduction process in every material as per this Fermi Dirac distribution and quantum concept. If it is true, then even if you can take semiconductors and insulators, the electron has to absorb the kT energy and they have to move to the empty level, and the conduction process should occur. But in insulators it is not happening. So this quantum theory unable to distinguish how the conduction process takes place in semiconductors and insulators and metals. So hope you have understood this session. We will meet in the next session to see the block theory.